Hey, what's up guys, my name is Gail. In this video I will show you how to build a super fast NAS using a Raspberry Pi 4. Now this is one of the easiest and simplest guides that anyone can use it to build a NAS server with Raspberry Pi 4. Now before starting this video, if you are a new viewer of this channel, don't forget to subscribe to my channel and consider clicking the bell icon to get notified whenever I post new videos. Let's get started. The only prerequisites of this video, you need a Raspberry Pi 4 or Pi 3, an external hard drive or SSD, which is where we store the data and can be accessed from any device. Now, as per my testing, you can use up to 4 terabytes of external drive. Now, if in case you're using any internal hard disk, now please make sure to provide an external power supply for the hard drives. Also, you need an Ethernet cable to connect to your Wi-Fi router or internet for Raspberry Pi 4. And last but not the least, the main one, a micro SD. You need a 16 gigs or higher class and SD card to install an operating system for Raspberry Pi 4. Now on your Windows computer, open your favorite browser. The first link will take you to this page. Now you need to download a Raspberry Pi OS. There are so many versions available, you can download any one based on your choice. I'm going to choose the Lite Edition, which is a command line based image file. Now if you want to use a desktop user interface of Raspberry Pi, you can choose the desktop edition. It's up to you guys which one to choose, anything should work fine. Next up, the second link will take you to this website. You have to download a software called Balena Etcher, which helps in creating a bootable SD card with Raspberry Pi OS. Now once it's done downloading all of the files from the links in the description, place it somewhere on your desktop for easier navigation. Now go ahead and install Balena Etcher on your Windows computer. Now go ahead, take the SD card and reconnect back to the computer. Then open Balena Etcher and then choose a select image option and look for the Raspberry Pi OS image file. Now go ahead, choose a select target option, which is going to be the SD card, and flash it. Now the flashing process will take some time depending on the writing speeds of the SD card. Now sit back and relax, don't interrupt anything. Now once the flashing process has been completed, eject the SD card and reconnect back to the computer. Now open My Computer, you can find a drive named boot. Go ahead, open the boot partition and highlight the address bar from the top and type cmd to open the command prompt from the current working directory. Now inside the command prompt, type echo, right angle, ssh and press the return key. Now this command will create a new file named ssh inside the boot folder, and this way ssh will be enabled automatically upon booting the Raspberry Pi. Now go ahead, connect the external drive or SSD to the computer, and we're going to properly format the SSD using an exFAT file system. Now keep in mind, this step is optional. If you're using the partitionized SSD or hard drive, then you can use this step, otherwise move on to step number 4. Anyway, this is my SSD which I have installed Ubuntu on it. I'm going to use it as my NAS drive. To format the SSD, open Command Prompt on Windows and run as administrator. Then type disk part. Then type list disk to list out all of the drives connected to the PC and make sure your drive is connected to the computer properly. Now in my case, disk 1 is my SSD. I'm going to select this drive by typing select disk 1. Then type clean to clean the system. Then type convert MBR to use a master boot partition mapping. Now once it's done, exit the command prompt. Then go ahead, open the disk management tool by typing diskmgmt.msc from search box. Then inside here, select the drive and create a simple volume using an exFAT file system. You can name the label as SSD or anything you want. Now exFAT file system helps us to store a massive files of any size, which is way better than the NTFS file system. Now once it's done, eject the SSD. Now insert the SD card into Raspberry Pi. Along with that, connect the SSD or external drive as well as Ethernet cable and power supply. Once everything has connected, turn on the power supply to boot Raspberry Pi 4. In order to communicate with Raspberry Pi, you need to know the IP address assigned by Wi-Fi router. To do so, log in into the Wi-Fi router and look inside the client section that may show the IP address of Raspberry Pi 4. At the end of this video, I will show you to set a static IP address of Raspberry Pi that will never change. Anyway, for now, use this method to find the IP address and note it down. Now using this IP address, we can connect to Raspberry Pi through SSH. Now open Command Prompt on Windows. If you're using the latest version of Windows 10 from Microsoft, the SSH command will be readily available to use. Now inside the command prompt, type SSH pi at and type the IP address of Raspberry Pi. Now in my case, it is 192.168.0.102 and then press the return key. Now accept the authentication key by typing yes and type Raspberry as a default password. Now keep in mind the default username is Pi and the password is Raspberry. Now you can see I have successfully logged into Raspberry Pi remotely. Now get ready, it's time to type many commands. Don't freak out, I'll guide you clearly, so watch this video carefully from here. Also write down commands somewhere on paper or I will leave the instructions down below in the description box. Now type the first command to change the default password of Pi from Raspberry to any strong password. To do so, type sudo passwd pi, then change the default password, which is strongly recommended. Then type sudo apt update and sudo apt upgrade -y to update or upgrade the system. Once it's done, type sudo apt install ntfs-3g to add in a support for NTFS formatted drives. Then type another command sudo apt install exFAT-utils space exFAT-fuse to add in a support for exFAT formatted drives. Then type sudo apt install samba-common-bin to install a Samba server on Raspberry Pi 4. Now once it's done, create a new directory inside the root. We're going to use this directory to mount the SSD. To do so, type sudo mkdir-m 1777/share. This is going to create a folder named share inside root. You can name the folder anything you want, but for now I want to make it simple. Now you can see a shared directory has been created inside root. Now type lsblk to see the connected drives and their mounting points. If you notice carefully, my SSD is connected as SDA1 and is not mounted anywhere. To mount the SSD to the folder which I have created inside the root, type sudo mount/dev/SDA1 and /share. Now after executing this command, the SSD will be mounted to the shared directory. Now you need to create a new user account to communicate with Raspberry Pi NAS. To do so, type sudo add user and type your name. The name can be anything. Now in this case, I will type my name, then create a user password. Once it's done creating a user, now type this command to set a Samba password for that user. Now keep in mind that user password is used to log in into Raspberry Pi and the Samba password used to log in into NAS Server. You can keep the same user password as a Samba password. Now type this command to configure your Samba. You can use any text editor. Now in this case, I'm using Nano to write a few lines to smb.conf file. Now inside this file, come to the bottom and add these lines. Once it's done writing the file, save it by typing Ctrl+O and type Ctrl+X to exit from the text editor. Now once it's done typing these commands, restart the Samba server by typing these commands. Now after that, we need to do a few more steps. Right now the SSD is mounted to the directory which we have specified. But Raspberry Pi, once it gets restarted, it will unmount automatically. Now to prevent this issue, we need to modify the fstab file that helps to auto-mount the connected drives to the specified mounting point upon booting. But first type sudo blkid to get the unique identifier string of SSD that will never change. Now in my case, my SSD is labeled as SSD. I'm going to go ahead copy the UUID string from here. Now before modifying fstab, I recommend you to make a backup of fstab file by typing this command. Then type sudo nano /etc/fstab and add these lines. Now first type uuid equals to and paste the string, then type the rest of the lines exactly in the same order. Once it's done, press Ctrl+O to save it and press Ctrl+X to exit the command line. After that, type sudo mount-a. If you don't see any errors, then fstab file has been successfully modified. Also, every time rebooting the Raspberry Pi, the IP address will keep on changing. Now, this will cause a problem for many users. To fix this issue, we're going to set a static IP address of Raspberry Pi that will never change. To do so, type this command and add these lines at the bottom of the file. Now keep in mind it's a case sensitive, type exactly what you see here. Now in this case, I'm setting 192.168.0.200 as my static IP address for Raspberry Pi 4. You can set any IP address between this series. Now once it's done, save the changes by pressing Ctrl+O and exit by typing Ctrl+X. Now go ahead and reboot your Raspberry Pi 4. Now after that, your Raspberry Pi will have the static IP address, which in my case is 192.168.0.200. Now it's time to connect to NAS Server and see how it works. Now on your Windows computer, open Control Center, then choose a Network and Internet, then select Network and Sharing Center, and select Advanced Network Settings and enable Network Directory. Now this allows Windows to see the networks in the same network. Then open Run dialog. Now type / and type the address of the Raspberry Pi. Now you will see a Raspberry Pi NAS server here. Now type the username and send a password to connect the NAS server. Now that's it. Now you have successfully connected to the Raspberry Pi NAS from Windows. Now as you can see, reading and writing the data to the NAS server works fine without any errors. You can also map the drive to automatically mount, which means you can see the NAS drive inside my computer without typing any login credentials. Now on your Mac, go ahead from the menu bar of Finder, choose Go and select Connect to Server, then type smb:// and type the IP address of Raspberry Pi, and then type the login credentials to connect to the NAS server from Mac OS. Now, if you're using Ubuntu, open the Files application. Then under the Locations option or Other Locations option, you may find the Raspberry Pi shown over here. Just select the Raspberry Pi from here and type the login credentials to start sharing the files. Now, if you're using iPhone, open Files application and click on the three-dot menu from the top right corner and choose Connect to Server option. Then type smb :// and type the IP address of Raspberry Pi and enter the login credentials to log in into NAS Server from iOS. Now inside the Android device, go ahead, download an application called LAN Drive and open it. Then select plus icon from the top right and enter the IP address of Raspberry Pi along with the login credentials to access the NAS server from Android. Now overall, I would say if you notice how flexible the NAS server, as long as if you're on the same network, you can connect to the Raspberry Pi NAS from any device and access the data. Now this way you can connect to your Raspberry Pi home server from anywhere around the world, but you need a static IP address, a static public IP address. For that, you have to contact your internet service provider to get that feature. And that's pretty much it. If in case you enjoyed this video, smash the like button down there and don't forget to subscribe this channel and consider clicking the bell button to get notified whenever I post a new video. Also check the article for detailed instructions down below the description for more information. If you have any doubts, comment down below. I will try to answer your queries. Thanks for watching this video. It's been KS Karail. I'll catch you in my next one. Peace.